Okay, and welcome everyone to what is, I think for us, and I hope everyone around the table, an exciting event. It's the first live event we've been able to run, I think, since February last year, anywhere in the world. So I welcome everyone to this Innovation Roundtable, which we're holding at the Fairmont in Toronto. Today our guest speaker is Kasia Borowski, and we're going to be talking about AI in construction and its place in innovation. So I hope everyone enjoys this presentation and the debate that's going to follow.
Thank you.
Kasia.
Yes, so my name is Kasia. I'm a managing director and co-founder at Brainpool AI, which is a global network of AI experts. We have over 500 members now. Most of them have PhDs in AI, machine learning, computer science, data science, and similar topics. My personal background is in mathematics and cognitive science, which is building mathematical models that predict human behavior. But what we do at Brainpool really is we try to apply the latest AI research to solve some of the most pressing business challenges. And we know that AI is applied everywhere now, from healthcare, manufacturing, retail, pretty much every industry is being transformed by artificial intelligence. But construction is one of the slowest adopters of AI technologies, and we know it will be completely transformed with AI in the next 10 to 20 years. And how do we know that? It's not just me saying it. We know it because it's happened many times in the past. So in the 1800s, the global population reached 1 billion people, which was a really fast growth from the 1700s, which is when the population was only at 600,000. So with the rapid increase of the amount of people, we needed to build more homes. Everyone needed a shelter, and it was no longer viable to actually carry the wood from the woods to cities to build your homes. So we came up with water power and steam power, and steam engines allowed us to transport the materials from forests, the wood from forests to the cities and build our homes much more efficiently. Then we go into the second industrial revolution, so about 1930, the population is about 2 billion people, so again, doubled in a short period of time. Again, there was a necessity for automation to increase our capability of mass production. We needed to make sure that the processes of building our homes and of building our infrastructure are much more efficient, and so we came up with burning coal gave us much more power, much more energy, and came up with steel, which was the beginning of the cities that we have around us today, the beginning of skyscrapers, and that was the second industrial revolution, enabled us further automation and to provide shelters for more people. Then fast forward 50 years, 1970s, we have 4 billion people living on the planet, again doubled in a very short period of time. And it was no longer viable for us to find people and go to speak to them, phone everyone up using yellow pages and find phone numbers manually. So we needed to digitize the whole process of connecting with people. And that's where computers came about. That's where we started having databases accessible to everyone, everywhere in the world. That's where the internet started. Google search came about, and that was the digital revolution of the 1970s, 1980s. And we now, going into the further phase, we now have 7.7 billion people, projected 10 billion by 2050. So the growth is exponential, and we are in trouble. We need to further automate. And so what the fourth industrial revolution is going to do, which has probably started a few years ago already, is going to allow us to further connect with the world of machines. So we've so far built machines that work really well. We are supported by machines every single day, but we're not very good at connecting with them yet. And the machines don't really fully understand the way that we operate, and there is a misalignment between the way that machines think and work and the way that humans think and work. So hopefully the fourth industrial revolution will allow machines to get closer to thinking like humans, and for humans to integrate and cooperate with machines much easier. So the future of AI, the way we see it, is really a partnership. It's where artificial intelligence works closely with humans and takes on all of the manual and time-consuming tasks, the repetitive tasks, to allow humans to focus on the creative tasks and things that matter to them the most, right? Because there's really no need for humans to be doing the repetitive tasks. They can really be taken on by machines. And just before we go any further, to clarify the difference between AI and machine learning, which I know a lot of people are still confused about. So you can think about machine learning as a toolbox to build AI systems. Machine learning is a set of algorithms, and each of those algorithms is typically tasked with a very specific task, very specific goal. What we normally talk about when we think about robots, such as Terminator or AI taking over the world, is we're talking about AGI, which is artificial general intelligence, which does not exist yet. So at the moment, what machine learning is capable of doing is to perform one very specific task for which it was programmed to solve. It's not capable of applying the knowledge in one area to solve a task in another area, which is what we humans can do. That's why we have the power of thinking about the creative tasks, or of thinking about abstract concepts which don't exist yet. AI is not able to do it at the moment. Machine learning solutions are there to perform the task that we designed it to do. Right, but we are here today to focus on construction, and so we've picked 5 top applications of AI in the construction sector. There are many more, but these are the ones that we feel are probably becoming more and more popular these days. So construction design automation. As we know, the whole process of designing a building, designing a house or a commercial building, is a really long and manual process, and there's many people involved in that process, and each of those people involved typically have different objectives, whether it's to minimize the total cost of construction, minimize the CO2 emissions, minimize the weight, or maximize performance or living space. So thanks to generative design, you can now go through hundreds of thousands of possible designs in just seconds. So generative design allows you to pick your objectives and actually see what is the difference between different designs when you select each of those objectives as primary goal. So if you optimize towards minimizing construction cost, what is that building going to look like versus if you optimize it towards reduced CO2 emissions? And here are a few examples. SpaceMaker AI is probably the most popular. Now it recently got bought by Autodesk for I think $400 million last year. Paraffin 3D, they focus on hotels. Evolve Lab, this is where the video is from. The second application is about planning, tracking, and management. Because we have so many different teams and people involved in every single process of building a new home or a new commercial building, it's really difficult to actually make them work efficiently together. So now you have software as a service platforms that allow everyone to see the same view, the same progress in terms of exactly when each team needs to come on board, when each team needs to talk to the other teams, and how they have to collaborate to make the whole process of designing and building structures much more efficient. So you can have a platform where you can track the progress, you can manage the logistics, and make sure everyone is on site when they need to be. There is avoidance of any unnecessary trips that don't need to be made at any given day. And obviously things like paperless contracting, so there's no longer a need to print anything out, to sign any paper documents. Everything is done within the software as a service platform to which everyone has access. On-site monitoring, so this is machine vision systems that are getting really, really good at detecting, predicting, and monitoring the progress on site. So this can be either in the form of cameras being placed on site or in the form of drones flying over a building. So machine vision can be used to detect many different things, but most of all it also predicts any risks that can happen on site. So machine vision systems are trained to actually get better at predicting all of those risk factors ahead of time and to hopefully prevent any safety issues that we might be encountering. But also it can be used to track progress against plan. So every construction site has a planned schedule, and machine vision can very quickly highlight which are the inefficient processes that are happening right now and where is the delay going to be caused. Robotics, so this is probably the more popular area of AI, which everyone thinks about robots when they hear AI, but it's true that robots will automate a lot of the manual processes. It's still quite early days, there isn't that many good robots that can completely take on the construction processes. Most of them are still being overlooked or done by humans. But here, for example, we have a process of drywall finishing done by this little robot that has machine vision system embedded in it, and then can precisely operate and finish a drywall. But apart from just robotics on site, there's also a lot of development off-site construction. We know that in the UK, off-site is probably more developed, especially in timber. Most of the floors and stairs, for example, are being pre-cut in the factory, which enables manufacturers to precision cut. So rather than bringing loads of timber on site and then trying to figure out how to best manage those resources on the site, you can now calculate everything, all the dimensions and coordinates using your computers in the factory, and then precision cut all of the pieces before you bring them on site. And digital twins. This is a really helpful tool that allows us for risk-free testing of different scenarios for development before we actually spend a penny building anything. So we can now have a full-on digital model of a house or a commercial building that can have a lot of detail in terms of all of the components of the particular structure, and we can then predict quite easily the impact of any design changes or things like weather disruptions or security events in the digital format of our building before we've actually built anything. Right, and we are here today obviously with Invent, who actually started their own journey with artificial intelligence, and we are very proud to be working with them on the project, which is to use AI to streamline data acquisition and insight generation in consulting. And I'll hand over to Ben to give a bit more detail on that.
Yeah, thank you, Kasia. So I think one of the key things, and you mentioned sort of at the beginning when talking about sort of why AI, for us, a lot of what we do in the consulting world requires, initially anyway, repetitive tasks. And another thing we find is that a lot of our clients are data rich and knowledge poor. So they have loads of documentation, lots of stuff they can provide us without really any clear insight into what that is. So there's a lot of upfront work just trying to make sense of what those documents are, where they are, especially when we come to looking at improving project operations, organisational improvements, and one of our sort of key services here in Canada, the SHRED credit scheme. So when you're looking at collating data, understanding what that data is, we spend a lot of time with our customers doing things that the person doesn't necessarily have to be involved in. So what we're doing and the journey that we've started on is very much about how can we improve that understanding of where data is, what data is that we're looking at, and how we can analyse, identify, and help sort of structure that data to gain sort of initial insights quite quickly on what we're looking at. One of our clients, when we do their credit report, for example, gives us 1 gigabyte of data every year. It's thousands of documents. That historically means I sit there for hours sifting through SharePoint site trying to understand that. Whereas what we're trying to build is, in some ways, it sounds simple, but it's actually sort of quite difficult. We're looking at developing something that will annotate those documents, that will give us an insight from the off of what those documents can contain. And as we move on, the next step is, well, how can we So that's really the machine learning part of it. You know, it's an algorithm that'll help tell us what these documents are. The layer of AI that comes on top of that after will be about how we can query that data, how we can gain true insight in that data, how we can get more than just, well, this document includes, you know, these keywords, which will save us loads of time, will help gain that sort of initial knowledge. And then once we start being able to query the data, that's when we can really start expanding on what we can use it for. We can use it to better understand and help people if they have commercial issues, help them understand whether a project is going well, and start to think, oh, well, are the telltale signs there, early days of it going wrong? And all we're doing really is creating something that will read lots of documents really quickly and help us gain that sort of initial sort of insight. So for us, data acquisition is one of our internal key bottlenecks. You know, we find that acquisition difficult, that getting documentation from customers, whether it be concerns about data security and all these type of things. But what we'll have is a platform based on ISO 27001, so it's best principles from data protection, but also something that can really quickly mean that, you know, you don't just have to give me a gigabyte of data, you can give me a terabyte of data, and I'll be able to go through it much quicker anyway. And everything we do will be better substantiated, better understood, all because AI will do that repetitive task more often, in black and white as well, which is a nice thing for an organisation or for an industry full of grey. We'll really be able to get that data sifted through quickly. So the current process is very manual, lots of back and forth, whereas the AI-powered process, that machine learning will analyse text data, create structured data through it. The model will automatically classify files so that we have a well understood structure, but also it'll be able to read the documents, and if 3 documents reference a fourth and the fourth isn't there, it'll be able to automatically generate an RFI. So then you start thinking about, you know, procurement processes and things like that, where, you know, you'll have 100 specs maybe, and it's the job of your estimating team will have you to go through them all. Does it all line up? Well, this will be able to read them all and say, well, is anything missing? Is anything contradicting itself? This is sort of long-term ambition stuff, but this is where AI can go once it learns and understands how to query the data in certain ways. So we are very early in our journey, but we're very excited about how we can free up time so that we can really create value for our customers with what we do. So back to you.
Great. Thank you. So yeah, we're also very excited to be part of this journey. So I think, you know, we convinced you all now that automation is inevitable. And just to recap, why automate? So you can save yourself a lot of money longer term. It is an investment up front, but longer term there is a return on that investment, and that will definitely continue to happen. You also gain competitive advantage. So automation is going to happen, and it's really just about who's going to lead that way. And obviously the companies that continue to process things manually will stay behind. This is just the reality of what's going to happen. So it's important to actually try to break on that journey with artificial intelligence as soon as you can. And improving staff productivity is probably one of the key benefits of automation of artificial intelligence. So we know that no one really likes to perform the repetitive manual tasks, you know, the things that we have to do every single day. So this is where AI can take on those tasks and actually allow your staff to be much more productive with their time.
It's not just productivity, it's morale as well, because
Sure.
if you get rid of the boring stuff, people are more engaged and interested in what you do.
Absolutely, it actually then improves the people's productivity.
Yeah, naturally.
Yeah. And overcoming bottlenecks to allow your business to further scale and grow. This is really what AI enables you to do. So now I wanted to just quickly introduce our own product in the construction sector, called Daisy AI, which stands for Design AI Systems. This is the first fully automated timber construction design software powered by artificial intelligence. So again, a very classic example of automation. So the process of designing a timber floor can take a structural engineer about 2 to 3 hours. And there's estimated 50,000 possibilities in which a simple rectangular shaped floor can be structured. If you think about the stair opening, the internal walls, your windows, there is a lot of possibilities. So DAISY goes through hundreds of thousands of possibilities in just a few minutes. So rather than a structural engineer trying to figure it out manually, DAISY does this whole process automatically using genetic programming. What genetic programming means is that it starts with a population of badly designed agents. So similar to human evolution, it's an evolution process. You start with badly designed flows, and then generation over generation, you get better and better at getting the right solution until the system converges, which is when you know you found the optimal design. And the optimal design can be optimized towards minimum cost of construction, or towards highest performance, or towards minimizing the waste that's generated. And so we know that the whole process of designing timber structures will be automated. We started with floors, and now, about a year after launch of DAISY in the UK, it now designs 12% of all floors in the residential timber housing market in the UK. And we are currently in process of introducing DAISY to the Canadian and North American market this year. I don't know if this is going to. Oh, there's no sound unfortunately, but I can voice over this. I've seen it quite a few times. So this is our client, Dr. Luke Whale from the Staircraft Group in the UK, just talking about how DAISY helps them double their productivity. So they had a problem that they had 4 factories producing timber floors and stairs. They are one of the biggest manufacturers in Europe. However, they weren't able to design those floors fast enough. There wasn't enough designers. They couldn't find the skilled designers fast enough. So instead of being able to produce 400 floors a week, thanks to DAISY, they now produce 800. So they managed to double their productivity using our tool. And they got their payback within a year. So they invested initially into building DAISY, but now, after a year later, they already see their money being returned, which is a great outcome. Right. So I think that was it from my side. Thank you very much. Hopefully, I convinced you that automation is coming, and it's just a matter of when.
Well, thank you very much, Kasia. That was a fantastic presentation and lots of food for thought. And I'm sure the debate will continue. So thank you very much for that.